Okay, last problem. Okay, so this one is 2016, number 1. So this is actually, since this is number 1, this was a calculator problem in 2016 as well. Again, you'll notice some similarities between some of the other table problems we've done, starting with an estimate, right? Okay, so one thing you'll notice about this problem is what makes it a little different from the previous problems is you'll notice my table is hours and my Y value is actually a rate. It's a liters per hour. So we're already given a derivative here. In the previous problems, we were given an amount of coffee in a cup and we were given the height of a tray, which is really just, none of them were rates. So this, not that it matters, but we do have a rate. What we also know is that this rate in this table is the rate of being water removed. They also gave us an additional equation, okay? But again, the additional equation is for something different. It's the W represents the amount of water being pumped into the tank. And they also gave us an initial condition of water in the tank of 50,000 liters that were being measured in. So this is like a variation of what we just did in accumulation. Accumulation, we did those problems where we had an in and an out, but this is an in as an equation, but an out as a table. So in this type of problem, the best we could do is estimate the amount removed. Okay, we can always find the amount added because we have an equation for that. We could always find the exact amount added, but we can only find an estimate of the amount removed. Okay, but this is a nice problem because it really, this one combines even more units than the previous two problems. So it does start with an estimate of R prime of 2. So again, find 2 points nearby. In this case right here, we're going to use 1 and 3. We're going to do 950 minus 1190 over 3 minus 1. Again, because we have a calculator, we can find that to be negative 120. They don't ask us to interpret it. They just ask us to indicate units of measure. Now realize on top, my change in Y is already liters per hour. Underneath it, I have a change in T, which is hour. So that is why we are going to have as units liters per hour squared, because I already have liters per hour and now I'm dividing it by another hour. Okay? All right. B asks us to do a left Riemann sum with 4 subintervals to estimate the total amount of water removed from the tank during the 8 hours. Okay, so again, they only want the amount removed. So I'm only using my remove table. But notice, they don't ask me for the amount removed. They ask me to estimate because that's the best we're going to do. And they asked me to estimate it with a left Riemann sum. So technically what I'm estimating is the integral from 0 to 8 of R of t dt, right? So that's what a Riemann sum will do, estimate this integral, because that would be the change in the amount from 0 to 8. If I integrate the rate of the amount being removed, I'm getting the amount being removed. Okay, so and one thing you're going to notice is we do not have even intervals, so we're going to have to do these separately. So remember, my first rectangle has a width of 1. The height I'm going to use is the height on the left of 1340. Okay, my second rectangle has a width of 2. I'm going to use the height on the left, which is 1190. My third rectangle has a width of 3. The height on the left is 950. My fourth rectangle has a height of 2. The height on the left is 740. Since we do have access to a calculator, we can just complete this and we get 80, 50, and in this case it would be liters. Remember, if you integrate the rate of liters, you're going to get the amount of liters. Okay, now they do ask us if this is an over or an underestimate. So if you remember with left and right Riemann sums, it has to do with whether we are increasing or decreasing. Now again, remember I've told you multiple times, in a table problem, you don't know what's happening in between unless they tell you, which they did on this problem. They told you that R of t is always decreasing. So again, it never goes back up in between, it always goes down. So since we have a decreasing function and it's a left Riemann sum, it is going to be an overestimate. You can memorize that or just use common sense, guys. If you look at the heights we added, did we add the 4 bigger heights or the 4 smaller heights? In a left Riemann sum, your bigger height is going to be on the left, which is going to push you up to an overestimate. So this is an overestimate. because R of T is decreasing. Okay? All right, the next question says, using your answer from part B, find the estimate of the total amount of water in the tank. Okay, so remember, I have rate being added. I have rate being removed. They want the amount in the tank. So I'm not integrating just this equation or just this equation. Remember that in the tank is the combination. It's any initial water in the tank, which is 50,000, plus the amount being added, which means integrate the add equation from 0 to 8, minus the amount being removed. Now again, notice they didn't say to find the amount in the tank, they said estimate it. The reason why this also has to be an estimate is because of the R of T equation, okay? So we can get an exact amount of this by integrating. So again, I put that in my calculator. I put into y equals, I already have that W equation. So again, all I have to do is integrate from 0 to 8, my y1 equation. Okay, so we get that. So that is 7836.195 minus this is what we did in part B. We already got that 8050 in part B. Again, they just want us to round this to the nearest liter. Normally it's 3 decimal places unless they tell us otherwise. So there we go. That is our answer, okay? All right, finally for the part D. The part D on this one is a little bit tricky, okay? So again, it says, is there a time when the rate at which the water being pumped into the tank is the same as the rate of water being removed from the tank? Explain why or why not. So this is a theorem question. Worst case scenario, you can give yourself a yes or a no and throw down a theorem. Okay, now again, this theorem is, if you weren't sure, again, it's between IVT and EVT for these types of problems. Okay, so this one, they're asking you about a time where they're asking you about the rates. Since both my equations are rates, do you see they're asking me not about the derivative of the equation I have, they're asking me about the equation I have. So this actually is an IVT problem. Since I have rates and they're asking me about rates, it's IVT. If it were MVT, they'd have to ask me about the rate of the rate, okay? So this is gonna be an IVT problem. So again, worst case scenario, if the most you know is it's gonna be IVT, throw down those words IVT. But they're asking me, is there a time where the rate being pumped in is equal to the rate being pumped out? Now, normally with IVT, we talk about numbers, right? We need a number before, we need a number after, okay? So when we say WT equals R of T, that isn't really numerical. But do you see, I could turn this into W of T minus R of T equals 0. Okay, so this is what I'm trying to show, that if I subtract these two equations, because they're the same, I get 0. So how do I show that something is going to equal 0 using IVT? Well, I just have to show that sometime before, at one point it's negative and at another point it's positive. It doesn't matter the order, but if something's negative and then it goes to something positive, it has to pass over 0 in between or vice versa. Since they're asking me about the interval 0 to 8, let's check that. So what I'm going to do is I'm going to check W of 0 minus R of 0. Let's check the low point of the interval. Okay, so W of 0, I'm going to get from my calculator. So let's go to the table. W of 0 is 2,000. R of 0, I look at my table, is 1340. Okay, and so here I get 660, right? So I get something positive. That's all I care, right? I get something positive. Now let's check the end of the interval they gave me, which is 8. So W of 8 minus R of 8. So if I look it up, W of 8 is 81.524. Okay, and then R of 8 up here is 700. right? So what I get is 81.524 minus 700 is negative 618.476. Okay, so because I go in that interval, I go from a positive to a negative, somewhere in between, it must be 0. Okay, so how do I see that, right? So remember, I need the conditions for IVT. The only condition for IVT is that it's continuous. How do I know it's continuous? Because they told me in the beginning that R is differentiable, which means it's continuous. W, they don't have to tell me it's continuous because I know equations, exponentials, are continuous functions, right? So since W of t and R of t are continuous, and, okay, W of 0 minus R of 0 equals 660, and W of 8 minus R of 8 equals negative 618.476. MVT guarantees WT minus R of t equals 0 in 0 to 8. Okay? And if you want, you could say, you know, which means W of t equals R of t, since that's actually what they asked you. Okay, but I imagine if you had that, because you have it up here, that W of t equals R of t means that, then you're fine without that last piece. Okay? So again, interesting little table problems for us today. Okay? And that is it.